Ladies and gentlemen, your attention please. We will start this conference at 8:30 a.m. Before that, I want to remind you, for the authors of the paper, please complete the IEEE copyright submission by creating an account at https://IEEE-pdf-express.org. Then enter the ID code of IC3INA 2023, conference 60834X, and follow the instruction. Once complete, please upload your final paper copyright submission statement file. For those who experience difficulties, we have provided a tutorial for uploading the final paper and copyright file via WhatsApp group. Please immediately collect all the necessary files so that our paper can be published by IEEE this year. For speakers and participants, after this event, e-certificates for speaker and participant will be distributed via email or WhatsApp group. Thank you. Ladies and gentlemen, your attention please. Kindly prepare yourself as the conference will commence. Your corporations is greatly appreciated. Thank you. And I want to remind you again, for the authors of the paper, please complete the IEEE copyright submission by creating an account at https://IEEE-pdf-express.org. Then enter the ID code of IEEE IC3INA 2023 Conference 60834X and follow the instruction. Once completed, please upload your final paper copyright submission statement file. For those who experience difficulties, we have provided a tutorial for uploading the final paper and copyright file via WhatsApp group. Please immediately collect all the necessary files so that our paper can be published by IEEE this year. For speakers and participants, after this event, a certificate for speaker and participant will be distributed via email or WhatsApp group. Thank you. Good morning, ladies and gentlemen. I am Elvira Nurfadila. I will be your master ceremony for today. I hope you all had a restful evening and are feeling energized for another exciting day of intellectual exploration and collaboration here at the International Conference on Computer Control, Informatics, and its Application, IC3INA 2023. The 10th of IC3INA is hosted by the Research Center for Data and Information Sciences, the National Research and Innovation Agency, BRIN, conducted virtually via Zoom. This year, IC3INA 2023 is highlighting, exploring the power of data, leveraging information to drive digital innovation. Yesterday, we had several keynote sessions with various topics stimulating discussion that showed this true depth of knowledge and expertise. From groundbreaking research presentation to thought-provoking panel discussion, we already witnessed the spirit of inquiry and innovation that define our academic community. It is great honor for me to introduce and welcome to honorable guest, Dr. Eng Budi Prawara, the Chairman of Research Organization for Electronic and Informatics BRIN, Dr. Esa Prakasa, the head of the Research Center for Data and Information Sciences, BRIN, Mr. Arafat Febrian Dirja, PhD, the chair of IC3INA 2023, Professor Mu Yan Cheng from National Cheng Kang University, Taiwan, Professor Dr. Anna Wenzel from Wageningen University and Research, Netherlands, Dr. Purnomo Husnul Khotimah from the National Research and Innovation Agency, Indonesia, and all honorable speaker and participant. First of all, let's say thanks God for giving us guidance, happiness, healthy, and mercy, so that we can attend and participate in this event. Ladies and gentlemen, I want to provide you with the outline program for today. This event will begin by playing the Indonesia Raya song. Before starting the first keynote session, we will do a photo session. For the keynote session in the morning, we will have two keynote sessions delivered by Dr. Purnomo Husnul Khotimah from the National Research and Innovation Agency, Indonesia, and Professor Dr. Anna Wenzel from Wageningen University and Research, Netherlands. We will have the third keynote session after the lunch break, delivered by Professor Mu Yan Cheng from National Cheng Kang University, Thailand. Before we begin, I would like to remind you again to fill out the list attendees via link provided in the chat. From presenter, please assign your username as code_of_room_name. For keynote speaker, please assign this username starting with the key_name. For moderator, in keynote session, it is the mode_name. For moderator, in parallel session, it is the mode_code_of_room_name. For PIC, it is the PIC_code_of_room_name. For participant, please assign the username starting with PP_name. Our committee will organize you according to your room in the parallel session. I announce you that in this conference, there will be award for 4 best paper from each track, as well as recognition for the top of 3 presenters. Good luck, and may you be one of them. Thank you. Ladies and gentlemen, before starting the keynote session, we will do a photo session. I would like to invite all speakers distinguished guests and participants to join a photo session. You are pleased to activate your camera. I will let Ms. Wardatul Hanifah as the PIC to guide the photo session. To Ms. Wardatul Hanifah, please.
Okay, let me take pictures. Start from slide 1. Slide 2. Slide 3. And last slide 4. Thank you.
Thank you. Thank you for being so cooperative. We will continue to the first keynote session. We will have a keynote session delivered by Dr. Purnomo Husnul Khotimah from the National Research and Innovation Agency, Indonesia. The session will be hosted by Dr. M. Teduh Wuliniansa from the Research Center for Data and Information Sciences, BRIN. Please welcome Dr. M. Teduh Wuliniansa to moderate this session.
Okay, thank you very much, Mrs. Fadilah. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. My name is Muhammad Teduh Wuliniansyah. It is a long name, but my friends usually call me Teduh. I am acting as the moderator of this session, and thankfully, our keynote speaker, Dr. Purnomo Husnul Khotimah, is already here with us. Good morning, Dr. Khotimah. How are you today?
Good morning, Pak Teduh. Alhamdulillah, fine.
Okay, thank you. Before this session begins, please allow me to read a short CV of Dr. Khotimah. Dr. Khotimah received her bachelor degree from the University of Indonesia, a master's degree from the Institute of Technology Indonesia, and a doctoral degree from Kyoto University, Japan. For years, she has shown extensive interest in many research fields, including big data, data science, data mining, recommendation systems, digital marketing for small and medium enterprises, traffic information systems, smart farming, and social media for disaster resilience culture. Dr. Khotimah received a fellowship in the GSPS Hope Meeting 2015 in her doctoral years. She also got a postdoctoral position at Kyoto University Hospital, Japan, from 2018 to 2022. The Japan Association of Medical Informatics at IC3INA 2019 rewarded her paper titled Medication Episodes Construction Framework for Retrospective Database Analysis of Patients with Chronic Diseases as the best paper. I am excited to hear Dr. Khotimah's speech today, and indeed, it will broaden our knowledge on horizons. If the audience has questions while Dr. Khotimah delivers her presentations, please write them in the chat column. Without further ado, please welcome our honorable keynote speaker, Dr. Khotimah. Dr. Khotimah, the screen is yours. You have around 45 minutes to convey your presentation, followed by a discussion session for about 15 minutes. Please, Dr. Khotimah.
Okay, thank you for the nice introduction, Pak Teduh. So I'm going to try to share my screen. So could you all see the presentation?
Yes.
Okay, very nice. Great. Okay, so good morning, everyone. Assalamualaikum warahmatullahi wabarakatuh. My name is Purnomo Khotimah, usually called by my middle name, Husnul. And today we're going to talk about the role of big data in digital epidemiology. And I think our topic today is very well aligned with the conference theme that is exploring the power of data, leveraging information to drive digital innovations. So as we could remember, I think from the pandemic, we could admit that big data have a big role in especially to drive the policy in the management and control of COVID-19 virus spreading. And before we go on to the discussions, I would like to provide a background about myself. So I think Pak Teduh has kind enough to read my CV, but I just want to put some highlight in 1 or 2 points of my research journey. So this is the time when I took my PhD degree in Kyoto University, where in this course I was firstly introduced to data science and medical informatics. At the time, we studied the medication pattern of patients with diabetes using prescription and patient condition data provided by Kyoto University Hospital. Okay, it's a bit jumpy. So in the study, we developed a medication episode reconstructions. This is due to the nature of the prescription. So they usually have gaps, such as like this, and then overlaps. And so we reconstruct the data set, and then they also develop a method to mine the reconstructed data. So we call this as singleton pattern mining, an extension of the association rule mining introduced by Agrawal. And I think there's someone talking. Okay, thank you. So using this method, we able to find a peculiar medication transition here. This is a green transition, which means the medication change when the patients are in ideal conditions. In the case of diabetes, it is rarely happening. So the physician usually don't change the medications when the medications have attained a good results. That means that the patients are in ideal conditions. And a domain expert confirmed this finding, and this finding is interesting for the doctors or the physicians because it provides an evidence that the doctor may change the medications not only when the patient's conditions are changing, but when new medications are introduced. Okay, that will lead me to my postdoctoral program, where here I have 2 projects. The first one is medical notes text analysis for medical coding tasks. And the second one is diabetic nephropathy risk prediction using deep learning. So in these 2 projects, we still use the same data sets, but here we mainly use machine learning. So the first project here, we use name entity recognitions to extract medical phrases for a medical coding task. So medical coding task is a procedure in insurance claims. So they use so a coder, a person who is in charge to code the medical notes, will transform the medical notes into codes, and that will be used for insurance claiming. And then in the second project here, we use CNNs to predict the progression of diabetic nephropathy risk. And these 2 points in my research course lead us to today's talk. So today we're going to cover about big data analytics with the emphasis in the history. And then we're also going to cover the digital epidemiology with focus on big data against COVID-19. And then lastly, I'm going to introduce our study in online news for monitoring COVID-19. So let's start with the first sections, that is big data analytics. So big data has been widely used in the early 2000s, but actually the first big data activities were recorded around 1660 by John Brown when he introduced statistical data analysis with the bubonic plague. So the London haberdasher published the first health records when he recorded death rates and their variations during the bubonic plague in England. And then in 1865, we have the business intelligence term coined by Richard Miller Devons. As we understand it, today, business intelligence is the process of analyzing data and then using it to deliver actionable information. And later, punch card tabulating machine invented by Herman Hollerith that and then used to process data from 1890 US Census. And later in 1911, Herman Hollerith then founded the computing tabulating recording company, which eventually became IBM. And then Nikola Tesla, maybe you already familiar with him. The notion of big data had been mentioned by him. That is when he predicted humans would one day have access to vast swathes of data via instruments that could be carried in one's vest pocket. So basically, Tesla successfully predicted our modern affinity for smartphones and other handheld devices based on his understanding of how wireless technology would change the world. As in his words, so when wireless is perfectly applied, the whole earth will be converted into a huge brain. And then Fritz Flömer invents a way to store information. So Flömer's process of laying metal stripes on magnetic paper eventually led him to create magnetic tape, which formed the basis for videocassettes, film reels, and more. And then in the 40s, we encounter new, the first computers that are ENIAC and then Colossus, Turing and Turing machine. On the note, on special note, Colossus here used to perform Boolean operations and calculations to analyze large volumes of data and is used to break NASI codes during World War II. And then in 59, a machine learning term is coined by Arthur Samuel, who is a programmer at IBM. And he then pioneered artificial intelligence that will be the backbone of big data analytics. And then, yes, then next is ARPANET. I think we all are familiar with ARPANET. It is the foundation of today's internet. And then in the 90s, GSM was launched, and this propelled the progress in the field of wireless communications. And then World Wide Web was developed and again drive the development of web-based applications. In 2001, Doug Loney coined the term of volume, variety, and velocity that define the dimensions and properties of big data. And this three V's encapsulates the true definition of big data and ushers us in a new period where big data can be seen as a dominant features of the 21st century. And then in 2006, Amazon Web Services starts offering web-based computing infrastructures known as now as cloud computing. And later, Amazon dominates the cloud service industry with about a third of global market share. And a decade later, just a decade later, in 2016, IBM reported that 90% of the world's data was created in the last 2 years alone. So this shows us that the immensely high of volume and velocity of data creations. So data that has been only created in 2 years dominates the entire data at the time. And then this is just to show the how to say how large big data impact towards the global economic. So in 2021 global market for big data estimated by 162.6 billion US dollars. Okay, and this is another way to look at big data evolution. So on the first phase, we are dominated by the structured content. So the data is stored in relational database management system. But in the second phase, we starting to see unstructured data with the booming of web-based system. And then in the third phase, a decade later until now, with the flourishing of technology of mobile and sensor-based, we are tracking mobile and sensor-based data. And with that introduction of big data history, I'm going to move to the next section of my presentations, that is digital epidemiology. So what is epidemiology? So here you could see an example of World Health Organization report on dengue fever happened in Sudan 2019. Here we could see where and when the dengue fever happened chronologically. So this is one of an example of epidemiology study. So the goal is of the study is to understand the distribution of who, when, where, and the determinants of health and disease condition in a defined population. However, the challenges in epidemiology study is that previously it was heavily dependent towards clinical data sets. That is data from doctor visits, lab reports, or conducting surveys. And of course, this will lead to time delay and a high cost. So for example, here we could see the hierarchical reporting system by healthcare institutions. So when an event of infectious disease happen, the authority will use the traditional channels to inform the higher authorities. So for example, if we have a dengue, a COVID, or here a dengue fever event, a clinic or a lab will report to the region authority, and then the region authority will report to the province, for example, province authority, and then the province authorities will report eventually to the national authority, and later the national authority will publish an announcement to the public. Of course, if we see these hierarchical settings of a system, then usually the traditional system is commonly slow, especially when it happens over the international borders. And that is when the digital epidemiology comes. So with big data analytics, digital epidemiologists conduct traditional epidemiological studies and health-related research using new data sources and digital methods from data collections to analysis. So informal sources such as online news, social media, and other online available data is leveraged by aggregating and then filtering the data to detect diseases, risk patterns, and its outcomes. And in the case of COVID-19 pandemic, here we've seen rapid spreading over a very short times. So the first case is identified in Wuhan in 2019, September 2019. And as for Indonesia, we confirmed our first case in March 2nd, 2020. And just 9 days later, the World Health Organization announced COVID-19 as pandemic. You could see here, this is the map of the COVID-19 case distributions. In 23rd January, the case is mainly concentrated in China, but only less than 2 months. This is March 11th. You could see that the COVID-19 has spread to all over the globe. And this precedent drives all the elements to fight and control the pandemic at the time, including big data. So in the early of 2021, we conducted a survey paper to understand big data role in COVID-19 pandemic. We collected data from Scopus database with the keyword big data and COVID-19, and we filter the database using a published date from December 2019 until January 2021. We attend 446 articles, and with another filtering to find the relevant articles, we acquired 92 articles. So from these articles, we identified that big data contributed at least in these 5 areas. They are healthcare, social life, business and management, government policy, and then also environment. And we could see here that the epidemiology study present in the healthcare area. We also found the usage of informal sources. So it varies from the IoT data, such as online media data. And then here we have IoT data such as GPS data, mobile devices for physical health records. And also other informal sources are in online media data, such as Twitter, Weibo. And then we also have public open data, institutional official data that are considered to be informal sources. For example, here we have the mask, face, head, pose, image data, and also the facial expression video and speech audio data. As for the methodology, the analysis are mainly conducted in both conventional, that is statistics and mathematics, and also more recent methods that are machine learning and deep learning. As you could see here, epidemiological study also done, for example, to classifications to study the psychological impacts of COVID-19, and then health protocol adherence. And as for clustering and LDA, used for studying the infected areas allocation, patients grouping, chronic disease distribution, medicine effect, and public concerns. Sorry. Okay. So from this study, we learned that machine learning and deep learning are the most frequent techniques used in big data analytics. This is due to their ability to give better results with the increasing amount of variety data. In addition, we also collected a wide range of big data technology provides opportunities not only to solve the current challenges, but also to solve the emerging challenges due to COVID-19, such as to identify new variants, vaccine effectiveness, side effects, relaxation of health protocols, and new normal adaptations, and medical waste management, among others. So for a more detail on the big data, on this study, you could check on our paper published in the Journal of Big Data and the Computing titled Big Data Research in Fighting COVID-19, Contribution and Techniques. Okay, so now I think is the last section of my talk, that is about online use for monitoring infectious diseases, which I think it's related with yesterday's keynote, Professor Paula, but she used a different approach, that is using geospatial data to conduct epidemic studies. So our study originally is intended for dengue fever. So at the time, I think it's early 2020. So we still don't have any concern on COVID-19. So the cases still mainly in the mainland of China. So at the time, I think Indonesia has a rise of dengue fever incidents. So dengue fever is a mosquito-borne viral disease and considered as the fastest spreading viral disease. And in 2001, World Health Organization state that Indonesia is one of the hyper-endemic region of dengue. Even until today, we are in the fourth position here in the 5 countries with the highest number of dengue fever cases in 2022. So even though we are not in the top, so the top here is Brazil, and then Vietnam, and then Philippines. So even though we are in the 4th positions, actually we are contributing 28.9% of death that occurred due to dengue fever cases. So an early detection is essential to to inhibit this kind of incident. And why informal sources? So in the era of big data, informal sources has been widely used, and it is reported by Gupta Kataria in 2020. Twitter is actually the most popular data source to perform surveillance research using social media text data. But I think we all know that Twitter is prone to noise, and then demographic bias, and then privacy issues. And lately, it is more difficult for us researchers to attain social media data source due to the corporate regulations. And in the contrary, we have this online news, and then it is reported by Koskova 2013 that it has a higher reliability compared to Twitter datasets or other social media data. And then there's still less works using online news, so there's an opportunity for us researchers to use online news as an informal data source. And of course, this here is a list of existing monitoring tools using online news. So we already have HealthMap, I think it's very famous. And then we have GPHIN, it's by Canada. I think this is Canada. It's owned by the Canada. And then we have GRIDS, and then MidICIS and Biocaster. However, these existing monitoring tools are dominated by the use of online news data using international languages. So there are still gaps in tapping online news media resources in other local languages, such as in our case, Bahasa Indonesia. And in fact, actually Bahasa Indonesia is the 4th largest language used over the internet, but yet it still has a limited NLP resources. And then there's already a study using Google Trends as the informal source, but it is only to find the correlation between Google Trends and a national dengue monitoring report in Indonesia. And the following is the dengue data sets. We created a corpus by querying news in one of the national online media, detik.com, using a simple keyword that is demam berdarah, or in English, dengue fever. And the query written of 151 records that span from the year of March 2004 until March 2020. And the following is the distribution based on the section assigned by detik.com. And how can we detect the event from the online news? So the common approach to detect events is by identifying words or phrases that spike, appearing a lot within a certain period. So from the data we acquired before, we classified the news into 2 groups. The first one is the news that are considered reporting dengue fever event, and the other class is the news that reports informations surrounding dengue fever, for example, health tips and so on. So the drawbacks of this approach will be shown by this graph. So we plot the news based on its time, based on the timestamp. And here the red is the news that reports the dengue fever event, and the blue one is the dengue fever information news. So you could see here in this region that there are spikes of blue bars, yeah, but little or no red bars. So this figure shows that how to say that it does not always necessarily means if there are spikes upwards with dengue, it doesn't mean that there was a dengue fever incident happening. So using the previous approach could lead to biased results if it's applied to our case. So in our case, we use the approach by identifying relevant news on dengue fever instead of detecting words or phrases by. So the following is the example of the online news. So here, for example, Peru is fighting against dengue fever in the middle of Corona. Consider this as event news, and the following is for the non-event news examples. And we consider the task as a binary text classifications because basically it's just identifying news into two categories, that is dengue fever non-event news and dengue fever news. And this is the distributions of the classes. So 64% of the data are dengue a non-event news, and then around 35% are event news. And the following are the classifiers, and the experiments is to find out the performance of basic classifiers, that is models with little tuning or customization. So actually we just choose the most common models for text classifications, MLP, and LSTM. And so here's the result shows that the CNN excelled compared to the other two, yeah, and it has a lower training time compared to the other two, compared to LSTM models, even though slightly high compared to the MLP. But as a lesson learned, we think CNN is how to say excel compared to these other two models. And then the results show that actually we are possible to detect infectious disease event from news titles, and we could generalize this model for other infectious disease events. For more detail of this study, you could go to a paper titled Deep Learning for Dengue Fever Event Detection using online. And the next study that we did was to understand the aggravation status of COVID-19. So aggravation status here is the news how to say, we try to identify whether the news report an event, whether the COVID is worsening or whether it is getting better. So we use a similar framework, but here for the labeling process, we use fold-based labeling. So the labeling is carried out by 3 respondents who labeled the news title based on its criteria, and the title label was decided based on the most votes. And the following is the criteria. So we have negative, neutral, and positive. And for the datasets, we use the news title of Indonesian online news portals. Here we have, I think, 7 Indonesian news portal, including Republika, Merdeka, Kompas, Tempo, Antara, Detik News, and Tirto ID. So these news portals were selected because of their reliability, speed of news delivery, and are verified by the Indonesian Press Council. In addition, another consideration is to have representation for local, national, and global news. And I think the following is the distribution of the sentiment classes. The data is dominated by the neutral, and then the negative news, and then the positive news. And from this study, we learned that so basically the experiment, because in previous study, we already know that CNN have a high performance compared to the other two models. So in this study, we chose using CNN. And in this study, we focused the experiment for the tuning. And actually, we can increase the CNN performance for the accuracy by 3%, and then for the F1 score is 7%. And again, for more detailed information about this study, you could check on our paper titled Classifying Exhibition Status of COVID-19 Event from Short Text using CNN. And next here is our next study, that is to develop a framework for monitoring an infectious disease using online. So we use the study case of COVID-19. So we extend the dengue fever study to to monitor COVID-19 infection events. And also we develop the framework. So from the news until so we can get the informations into our mobile, or even our in our mobile devices. So we also develop the API applications. And also one of the difference compared to the dengue fever is that we also implement BERT as the state-of-the-art language model for classifications. And the following is the data set. The classification is similar with the dengue fever, basically 0 for the non-event news and 1 is for the event news. And the following is the distribution of the data set for each portals. And this is the total distribution for the event and non-event news. So you could see here that the data set is rather imbalanced. And the following is the results. So BERT with fine-tune is actually excelled significantly compared to the other two, even though I think CNN and also logistic regression also provide good performance, but BERT comes to number 1. And also we try to look at the coverage of our data set. So we extract the key information from the collected news. And here's all the key information we collected. So for country example, we have 59 unique. And then after the duplication, we have 51. And then for the region, we have 21 regions collected. And after the duplication, we have 18 geo information collected, and so on. So we transform these geo informations to the map. And then you could see here, this is our own map compared to the maps that are created by Johns Hopkins University. So you could see here the map is quite similar, even though here in some area of South America and Africa, here we don't have any we don't have any incident here. This is due to we do not map the region. For example, we have a news that reported South America. We don't then automatically map that to cover the whole South Africa. But basically, our data set could, report the important incident in a global, a more global level. And then the following is the mapping for our national area. So this is our mapping, and the following is the mapping from the COVID-19 case based on Kawal COVID-19 Indonesia dataset. So the map also looks similar. So we have the red region also in I think West Java. This one is also West Java and East Java. Okay, so from this study, one of our highlight is that our implementation is able to identify the UK strain event 13 days before the local authority announcement for international entry restriction. That is on December 28th of 2020. So this shows us that using informal sources such as online news, we could possibly give a more faster information to the public to raise their awareness. For more infos in in our study, you could check on our paper that is titled Monitoring Indonesian Online News for COVID-19 Event Detection Using Deep Learning. I think my slides are a little bit jumpy, and I remember I have this one background. I think I haven't covered it yet. Wait. Okay. So I think I haven't covered this yet, yeah, Pak Teduh.
Yes, I think so.
Okay.
Sorry.
So to give a perspective about why we conduct this study is that so pre-COVID we have this traditional concept that focus on personal health, which means that an individual is responsible for one's health. However, due to climate changes and then human behavior, we have these EIDs becomes more common and be part of our life. You could see here that in 2003, we have SARS, and then a decade later, we have MERS, and then just by 2 and then 3 years later, we have Ebola and Zika in a row. And later, we have a COVID-19 pandemic with a more vigorous virus characteristics. Yeah, so they have a high rate of survivability and then rapid and easy transmissions. So with this kind of virus characteristic around, an individual health could impact the community's health. So we cannot just use the traditional health concept anymore. So we need to realize this community's health. So that is an individual health contributes to the community's health. And we can achieve this community's health with the requirement of communities public high awareness, and also with proper near real-time public monitoring tools. So awareness here is public awareness is a very important essential factor to avoid us from calamities such as pandemic as just happened in 2020. So I hope this gave a good background why we conduct the study of online news for monitoring infectious disease event. Okay, so I'm going to. Do I still have time?
Yes, we have plenty of time. You still have 11 minutes, but it's okay.
Okay, 11 minutes. Okay, so I think, okay. So I think that is a good time. I think I can finish my time on time, my slides on time, just a little bit more. So the following is our prototypes that is siap ya. So it's actually a pun for ready. So we need to be ready for the incident of infectious disease. The following is our prototype. It's a mobile applications. So the following is the home screen that is basically just show all the news, the online news from these portals. Yeah, so this is the channels, Antara, CNN, and so on. And then the following is the display for the filter setting menu. So we could show all the news and only the event news. Yeah. So if we activate these settings, then we could see only online news that are reporting the incident of COVID-19 infection disease. Okay, and this is our latest prototype. In this prototype, we already we added the feature of agrivision status. So we convert the agrivision status into color codes. So for the blue one is for the neutral, and then yellow, orange here for the negative one, and then green here is for the positive online news. So for the next direction for our study is that we would like to achieve an early warning system for infectious disease. So we have performed an analytical study to understand the correlations between online news publications correlate with the epidemiological data, such as the national case number and the effective reproductive number, RT here. So basically what we do is that we compare the numbers of news with event and non-event labels, and the numbers of news having the sentiment of negative, neutral, and positive with the epidemic data, and then we analyze it with using correlation and regression analysis. And the following is the distribution of the news. So the blue one is for the event, and then the red one is for the non-event, and then the yellow is for the total news, and for the dashed line is for the national cases numbers, and the green dashed lines here is for the RT national number. So you could see here, if we just looking at, so the left one is for the event and non-event data, and the right one, the right figure is for the sentiment data. So just using my eyes is actually the online news and with the epidemiological data is highly correlated, positive correlated, and then I think this is the negative correlated. And we acquired the correlation score for the event, non-event, negative, and neutral positive with the confirmed case, death case, and activist case, and recovered case. So in this case, compared to the other data, event news, I think this other correlation score here, the total news, but I don't think I put it in this case, in this slide. So actually, the event not only excel compared to the other numbers, non-events, negative, neutral, positive news, but also the total total news. Yeah, so the news that reporting the event have higher correlations compared the other numbers. And these results, we also check the feature significance between media and academic data. Here we have the p-value is under 0.05, I think. So it means that it has a significance between media and academic data. Okay, so here we have from the study, the lesson learned is that the results suggest a stronger correlations for finer classifications for correlation number with confirmed cases. So it means that how to say, we actually could use online news to maybe predict the trend of the infectious disease. So I think for next study, the direction of our research is moving forward to time or trend analysis of our online news timelines. I think I haven't put this study. I think this is the study we've done in 2021. It is about the time series analysis for of online news for COVID-19 in I think in IC3INA in 2021. And then as a closing remarks, yeah, as I've mentioned before, that emerging infectious disease has become a serious threat for our global health and humanity. And as you could see here that, how to say, more and more new emerging infectious disease. And I think the last time I've heard is there's a Nipah virus emerge. And then, and also due to the global rapid movement of people and goods increases the latent danger and potential for the spread of disease across international borders. And from the COVID-19 pandemic experience, it proves that timely preparedness of each stakeholders, especially the public, for EIDs is urgently needed. So I guess that concludes my presentations. If I still have time, so I would like maybe to introduce our research group. So I am from Information Retrieval Research Group of Research Center for Data and Information Sciences. So here are our members, and currently we have a postdoctoral, Dr. Rifani from Jambi. And then we also have an interns from UPI and from Undip. And the followings are our recent activities. So we have the online monitoring online use to identify emerging infectious diseases. And then we have this text-based processing to support trip planning system in autonomous vehicles. And then we also have how to say, food and beverage industry analysis on public opinion on halal food based on social media. And also we have, how to say, research on maps, yeah, satellite image analysis for developing large-scale disaster-based land use maps. And then we also have research on chili varieties. So we use big data to identify the varieties based on their leaf features. And then we have text mining based processing to support the seaweed biodiversity identification system. And then Also, we have the identification of coffee bean roasting image color using image processing to predict coffee bean maturity level. And the following are activities in our research group. This is for the intern activities. So basically, we have a regular meeting, and then we use basically data processing and not only machine learning but also statistical methods. And basically, and usually we publish the results to publications. So some of our publications are supported by the students. And the following are our collaborators. So currently we have many collaborators from the academic or even from a research center here, and also from government. And I hope in the future, because this is an international conference, I hope we could also have more international collaborations. And so let's connect with us, and terima kasih. And the following is if you would like to check for my other activities, I usually post my recent activities in LinkedIn. You could check on my name, Fatimah. And for more infos, you can contact us regarding the researches or any others issues on my email at BRIN.go.id. Okay, thank you, Pak Teduh. I hope I don't take much time.
Thank you very much, Dr. for such an talking from the history of big data to on role of big data in digital epidemiology for tracking the events of dengue fever and COVID-19. Dr. Khotimah mentioned that one of her research highlights is that the implementation of her method was able to identify the COVID-19 UK strain 13 days before the local authority announced the strain. Please give applause to Dr. Khotimah. Okay, we are now in the QA session. I see there is one question for you, Dr. Khotimah. Should I read it or okay? Thank you, Dr. This is from Miss Siska Pipiana. Her question is or her comment is thank you, Dr. Husni, for the interesting presentation. I would like to ask, based on your experience, is it possible to use news articles to do sentiment analysis? Because we know news basically considered as a neutral sentiment. Can you give any difference to sentiment analysis using Twitter or news articles and uniqueness from its kind of data? Thank you.
Yeah, sorry. So yeah, thank you for your questions. Yeah, yeah, it's true that news is considered to be neutral, but actually we kind of like tweak the sentiment analysis to identify the aggravation status of COVID-19 at the time. So in the news, they they report many kinds of status of COVID-19. For example, you have the news that report, for example, the patient numbers are increasing. So for those kind of news, we consider that as a negative sentiment news. And then for example, news that are not related with the infection event, we consider that as the neutral sentiment news. For example, the news about some fundraising for COVID-19 casualties, and then the negative sentiment news is for the news that reports a good, for example, the decreasing number of patient conditions. So usually sentiment analysis is used to analyze the public opinions, for example, for some things. But in this case, we tweak those concepts to to our case, that is to understand the aggravation status. So aggravation status here means that whether the disease event worsening or getting better. So, and then, okay, so the differences, and for the next questions, the differences between sentiment, using sentiment analysis for Twitter and compare it to news articles. So for us, using a news article, it is one of them is to avoid hoax news. Yeah. So we selected the one of the considerations of the portal news that we selected as a data source is that the portal news should be already been verified by the press, by the Indonesia Press Council. Yeah. So that will decrease the the chances, the probability that our data are hoax news. And then this is different with Twitter dataset. So in social media dataset, it is prone to noise. Yeah. So we cannot really understand. So you need more pre-processing. You need to apply more processing techniques to differentiate between bot posts or the real post. Yeah, the real person post. Yeah, and so in that sense, using online news, we we only need less works in the processing. In addition, for the case of Twitter, they usually use slang words. So sometimes you need additional pre-processing. For example, maybe you need to change the slang words to identify and then change the slang words. And also maybe you need to delete all the stop words. In our case, because journalists usually have editor to edit and check their manuscript. So in our observations, our data usually have less typos, yeah, and rarely use slang words. Yeah. So that is maybe the differences between using social media data and then compared to using news articles. I hope my answer could, my explanation could answer your questions.
Thank you very much, Mrs. Khotimah and Ms. Pepiana for the questions. Okay, I don't see any questions. Okay, while we are waiting for the audience, for the questions from the audience, may I ask some questions, Mrs. Khotimah? Okay.
Yes.
So perhaps I'm wrong, but I noticed that you use headline news in your research, not the content news. I mean the news content. Are you planning to use the news content also? I'm asking because for me sometimes the headline is sometimes confusing, and we can only comprehend the headline news after reading the news content. For instance, once I read the headline news, the Earth's share price is soaring up. I was perplexed. I mean, who is trading our Earth? After reading the news content, I learned that Earth is the name of a company. So, your opinion, Ms.
Yes,
Khotimah?
thank you for your input, yeah, Pak Teduh. So in our last research, actually, we don't use the whole content of the news. So this is because to read all the content of the news, then we will need a more more respondents and more time, yeah, to check one by one all the news. And also because how to say, this is a mainstream portal media, so they are all very respectable portal news, and we consider that the data is how to say already been how to say they so for the mainstream media, for example, this kind of portal news, they need to publish news that in accordance to a code ethic for journalists. So that should be a good guarantee, I'd say adding a guarantee for our data verifications. And but surely enough that in our data we but how to say, of course in the future maybe with more resources we could also to add more guarantee to the robustness of our data, then we could also use the whole content of the data. But I think many research directions can use the whole content of the news. For example, to identify the entities that is how to say, that are present in the news. For example, the locations, and then the subject of the news, for example, that can be used for example, to understand the process of infectious disease of COVID-19 management. So that could maybe useful for in the future for the management of infectious disease event.
Okay, thank you
that is
very.
my opinion.
Okay, thank you very much, Mrs. Khotimah. We are still waiting for okay. Still not okay. Let me ask another question, Mrs. Khotimah, if you allow me. Okay. Is there any reasons why for tracking the events of creating the data set you mainly use news from the big website, while for making the COVID data set you also included articles from other websites? I mean, what are the perhaps when you strike the news is mainly on the tick, or maybe other reasons?
Oh yeah, so in the dengue fever study, that is our earliest study, our earliest attempt, yeah, to use online news for monitoring infectious disease events. So at that time we only have a little time, yeah, say very limited time to acquire data. So we only use the detik.com at the time, because detik is I think the most popular. I think detik is one of the first portal media, yeah, compared to other traditional media such as maybe Jawa Post, Kompas, and so on. Detik I think is the first one of portal online news. So that is why we use detik.com in order to get more data. Yeah, so I hope we could, and it is proven in our data set, we can get news as early as 2000. I think from 2000, yeah, from 2000, from the years of 2000s. Yes.
So, so the reason is more because of time limitations. I see. Okay, thank you, Mrs. Husnul Khotimah, for your inspiring research, for your sharing presentations, and we have our time is limited. Now it's 9:45. Thank you again, Mrs. Khotimah, for your such a great speech, and thank you also to the audience for their attention and support. Ladies and gentlemen, please give Dr. Khotimah a big virtual applause. I'm returning the screen to the MC, Mrs. Nur Fadila. Thank you very much again. Thank you. Please, Mrs. Elvira Fadila.
Okay. Yeah. Thank you, Dr. Purnomo Husnul Khotimah and Dr. M. Teduh Uliniansa for the interesting and informative session. We want to give a token appreciation to Dr. Purnomo Husnul Khotimah and have a short photo session. For Ms. Wardatul, please take the photo. Okay. So ready, Ms. Wardatul? Okay. Okay. We want to go to next agenda. Again, let's give our virtual applause to Dr. Purnomo Husnul Khotimah and Dr. M. Teduh Uliniansa. The next keynote session is delivered by Professor Tony Toharudin, PhD, from Pajajaran University, Indonesia. The session will be hosted by Dr. Eng Budi Nugroho from the Research Center for Data and Information Sciences, BRIN. To Dr. Eng Budi Nugroho, the time is yours.
Okay, thank you very much, Elvira. Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone, and good morning, Professor Tony Toharudin. I hope you already in this main room. Welcome to IC3INA 2023. My name is Budi Nugroho from Research Center for Data and Information Science, the National Research and Innovation Agency. I will be responsible for hosting this presentation today. I was informed that Professor Anna Wenzel would not be able to join us in the session, and I'm glad to welcome our next keynote speaker, Professor Tony Toharudin, PhD, who will present about the development of education in Indonesia, a perspective from data science. As written in this screen, Professor Tony Toharudin, PhD, was graduated from KU Leuven, Belgium, in statistics, and have the doctoral degree in 2006 in spatial analytics at Groningen University, Netherlands. His research interests in data science, time series, machine learning, statistic forecasting. He has many achievements, such as he is a professor in Science and Data in Department of Statistics, University of Pajajaran in Bandung, and Kepala LL Dikti Wilayah 3 dari tahun 2023. Kepala Badan Akreditasi Nasional Sekolah Madrasah BAN SM 2018-2022, dosen berprestasi Fakultas MIPA Unpad 2015, Satya Lencana Karya Satya 2012, Satya Karya Bakti 2012. And if you would like more information about his experience and biography, you can access in the website of Pajajaran University, or just simply Google his profile. And now here's our keynote speaker, Professor Tony Toharudin. The screen is yours.
Okay. You hear my voice?
Yes, very clear.
Okay. Thank you very much for the opportunity. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Good morning, everyone. Would you please share my PowerPoint, please?
The PIC for this session, please help.
Oh, okay. Ladies and gentlemen, respected guests, I'd like to express my heartfelt gratitude for your presence here today. For your information, it has been more than 30 years since I began my journey in the field of statistics, starting at Pajajaran University and graduating in 1994. And I continued my study to KU Leuven to take a master degree in statistics, 2004, and completing my PhD degree in Groningen University, 2010. Next slide. So this is my book reference. I made already 4 books, and one of the books together with Regi to publish apply science data in public policy using RStudio. Next slide. Okay, this is my focus on my research. So if you see word cloud, if we have a keyword of wider forecasting or time series, artificial neural networks, I already published some articles related to my competency, and one of the publication related to COVID-19 2022, I think. Next slide. So in this presentation, there are 4 pillars I will discuss. At first, about the position of Indonesia in 2045. And the second, what data science actually means. And third, how to maximize the issue of the metaverse in the field of education. And fourth, how to maximize data science for Indonesia demographic bonus. Next slide. It is widely known that ambitiously we aim to elevate ourselves to become a high-income country and the world's largest economy by 2045. In 2045, Indonesia will celebrate the centenary of its independence. In that year, Indonesia has the potential to achieve various development and transformation goals. Yeah. Of course, predictions about Indonesia condition in 2045 are speculative and depend on various factors, including government policies, economic developments, social changes, and global dynamics. Let's take a look at what's happening in 2023. First, gross domestic product, GDP, in 2023 stands at 1,385 US$. Second, Indonesia's economy in the second quarter of 2023 grew by 5.17% year-on-year. Third, the manufacturing sector consistently contributes significantly to growth. And the fourth, processing industry and CPO, crude palm oil, grew positively by 5.33%. And the last, agriculture grew by 0.34%, with a contribution of 11.77%. According to PricewaterhouseCoopers data, with an average economic growth rate of 7%, Indonesia is expected to achieve a GDP of 9.8 trillion US$, ranking among the top 5 in the world, or a GNI per capita of 30,000 US$, reaching upper middle income status by 2045. Certainly, this ambition can be realized with the support of quality human resources provision in technology, and productive human resources. Next slide. Education and skill development are key in investing the post-digital economy. People need to continuously update their skills to remain relevant in a rapidly changing job market. Data science plays a crucial role in the development and operation of smart cities. Data science enables cities to collect and analyze data from various sources, such as IoT sensors, transportation system, city infrastructure, and citizen interaction with city services. This data analysis can provide deep insight into how cities operate and how citizens interact with their environment. Next slide. Next slide. Oh, sorry, sorry. Yeah, digital technology continues to evolve, and companies must adapt continuously to stay relevant. Innovation like artificial intelligence, IoT, and blockchains continue to influence various economic sectors. Many businesses undergo digital transformation, which involves using technology to enhance operational efficiency, create new business model, and also interact with customers digitally. This can entail significant change in how business are conducted. Next slide. So what is meant by data science? Next slide. Data science is multidisciplinary field that involves understanding, collecting, analyzing, visualizing, and interpreting data to generate valuable insight and support decision making. First, data, raw facts or number without meaning or context. And the second, information, processes data that has meaning. And the third, knowledge, a deeper understanding of information. And four, insight, a deep understanding of a topic or situation that can result from creative thinking and in-depth analysis. And wisdom, the ability to make good decisions based on knowledge and experience. In the context of learning and decision-making, the journey from data to insight involves a gradual process of processing, analysis, and also interpretation. Data serve as raw material, which is then transformed into information, expanded into knowledge, used to develop wisdom, and ultimately can yield valuable insight. Each step in this journey plays a crucial role in the decision-making process and a deeper understanding of the world around us. Next slide. So now data science and statistics are two fields that are often closely related but have different focus and different approach. Data science use various tools and techniques such as programming, artificial intelligence, machine learning, and in-depth data analysis to process data and generate insight. Data science is used in various fields, including business, social sciences, natural sciences, health, and many others. It is used to make product recommendation, forecast market trends, identify fraud, and perform many other tasks. Statistics is a discipline that focuses on data collection, analysis, interpretation, and also presentation. It employs mathematical and statistical technique to analyze and generalize data. Statistics use techniques like calculating mean, median, standard deviation, hypothesis testing, and statistical regression to analyze data. Statistics often incorporate probability concepts into its modeling. Despite these differences, it's important to note that data science and statistics often complement each other. Data science can leverage traditional statistics tool in its analysis, while statistics It's used in the interpretation and decision-making stage of data science. In many data science projects, a strong understanding of statistics is essential to accurate and relevant analysis. In data science, deductive and inductive are two different approaches used in the analysis and drawing conclusion. Differences between deductive and inductive in data science. Deductive start with a general hypothesis and seeks evidence to test that hypothesis. And inductive start with specific data or observations and seeks patterns or trends to make more general hypotheses. In some concepts, data science makes us more opportunistic to maximize all available data and choose what is important, also known as a feature selection or feature importance. Next slide. If we look to this slide, so the 12 phases of big data is a concept that expands upon the three commonly known volume, velocity, and variety to describe the characteristic of big data. And if you can see here, the 12 phases of big data. At first, volume. The amount of data is large. And the second, velocity, the speed of data collection and processing. Variety, the diversity of data types of formats. Value, the benefits that can be obtained from data. And veracity, the level of reliability of the level of reliability and accuracy of the data. And next, voluntariness, emphasize the importance of privacy and individuals' right to control their personal information in the big data environment. Vagueness, the degree of uncertainty or lack of clarity in data. And the next, vocabulary, data model and semantics that describe a data structure. And variability, dynamic behavior that evolves in the field of data. And virality refers to the spread of content or information by one user and received by other users for their own use. And venue, the location or platform where distributed and heterogeneous data is collected from various sources or different platforms. It refers to where the data is discovered, stored, and processed. And the last, validity, in the context of data quality, data governance, and master data management, it refers to how accurate, relevant, and suitable for its intended use the data collected, stored, or used it. The concept of the 12 of big data is important as it helps in better understanding and managing big data, including aspects such as data quality, value, security, and data innovation. It enables organizations to make better decisions, improve efficiency, and also meet data protection regulation. Next slide. So the metaverse now has become an interesting topic in education since 2022. Yeah, the metaverse offers a virtual environment that can be used in an educational context. School and universities can leverage the metaverse platform to create interactive and immersive learning experiences. This can include virtual lectures, tutorial, and also simulation in a 3D environment. Here is maybe the next slide. There is interesting video you can see.
All right, perfect. Oh, hey, Mark. Hey, what's going on?
Hi, Mark. What's up, Mark?
Whoa, we're floating in space? Who made this place? It's awesome.
Right? It's from a crater I met in LA.
This place is amazing. Boz, is that you? Of course it's me. You know I had to be the robot, man. I thought I was supposed to be the robot. Whoa.
I knew you were bluffing.
Hey, wait. Where is Naomi? Let's call her.
Naomi.
Hey, should we deal you in?
Hey. Sorry, I'm running late, but you've got to see what we're checking out. There's an artist going around Soho hiding AR pieces for people to find.
3D street art? That's cool.
Send that link over so we can all look at it. This is stunning.
Okay, that is something.
That's awesome. Wow.
I love the movement.
Wait, it's disappearing.
This is amazing.
Hold on. I'll tip the artist and they'll extend it.
Wow. Brilliant.
If you guys like it here, I have another room that you're going to love. Check out this forest room.
Huh, let's see it.
Koi fish that fly? That's new.
This is wild. Hey, one sec, Boz. It's Priscilla.
Hey, you have to see this. Beast is going crazy.
Oh, I love that guy. We've got to show that to the kids. Can you also send that to my dad?
I'll message him.
All right, see you at home. This place is great, Boz, but there's something I got to get back to.
Okay, ladies and gentlemen, the metaverse allows students and teachers to interact in an engaging virtual environment. This creates opportunities for better collaboration among students, even if they are in different geographical locations. Students can gather in virtual space for discussion, collaborative projects, and also various social activities. However, it's important to remember that the use of the metaverse in education also comes with ethical challenges and consideration that need to be addressed, such as privacy and data security issues, accessibility, and the potential for inequality in access to technology. Additionally, this technology is still in the development stage, and further evolution will continue to occur. Therefore, education in the metaverse is an exciting field to monitor as technology advances. As evidence, if you look in the slide, South Korea, China, and the United Kingdom are among the countries conducting the most research on the metaverse in the field of education. And Malaysia is one of the Asian countries showing interest in this research, but Indonesia still lags significantly behind in research in this field. Next slide. The metaverse allow students and teachers to interact in engaging virtual environment. This creates opportunity to better collaboration among students, even they are different geographical location. I said already before. Another research result from the Center for Sport and Exercise, University of Hong Kong. This video demonstrates computer vision for recognizing swimming movements, which can serve as a reference for assessing whether someone is swimming correctly, and as early warning system if there are any unwanted incidents while swimming. Next slide. The metaverse can be used also to create realistic testing and simulation. This allows students to test their knowledge and skills in a safe and controlled environment. For example, in this video, realistic cloud simulation in sound. The metaverse can be used to training in the field of design. Next slide. Another example. Please move the slide. Okay. Another example is a plain sight introducing vision, artificial intelligence for accurate livestock monitoring. This research is also useful in the field of animal husbandry. This research can accurately detect animals to classify and determine the number of animals. Registration zones where object detection and tracking are applied when an object enters the camera's view. Counting lines that trigger object counting each time they pass the line, if you see in the video in this slide. So next slide. So what can we maximize in the demographic bonus? Next slide. Now, if we look to this slide, so we identify the problem of education in Indonesia, and we can see the indicators main performance for higher education. There are age, we call it IQ, yeah. We have age IQ, and every higher education have to achieve all of the IQ in that higher education. Next slide. And this is also our Ministry of Education. There are some episodes to increase the quality of education. Yeah, for example, in episode 2, we have Campus Merdeka, and episode of 19, we have Indonesian Education Report. This is related to large data or big data in our ministerial policies. So if we focus on this data, we can improve time by time about education in school or higher education. So I think all of the policies now related to how to improve the quality of education in Indonesia. Next slide. So now we see about the demographic bonus is a phenomenon where the majority of a country's population in the productive age group, typically between 15 and 64 years old. This can create significant economic opportunity if we manage well. To maximize the demographic bonus in Indonesia, based on my expertise, there are 6 aspects to consider. So at first, maybe next slide, yeah? Okay, so one moment, please. If we look to the best practice policy, yeah, at first we see that pentahelix, so collaboration between 5 components in pentahelix, government, collaboration with media, collaboration with community, collaboration with academic, and collaboration with business and industry. Each one the strategy for increasing the quality of education in our country. And the second is creation of precise and targeted indicators. And the third, strengthening infrastructure and suprastructure. And the next, big data analytics implementation strategy, because in our environmental, we have big data, especially in education. And public policy and law based on research. And the 6, enhancing the relevance of education and employability of graduates in the job market, as we see in the slide before. So 7, supports analytics and aids improving the quality of work-based vocational education through industry collaboration. As we have in the policy of our ministry now, yeah, to increase collaboration with industry and business area to improve the competency of all students, yeah, based on a collaboration with industry. And the 9, enhancing digital skills of the Indonesian society. So as we see in the many policies from our governments to increase digital skill or digital literacy of Indonesian society. Next. So that's my PowerPoint presentation, and maybe this presentation can use for all participants here. Thank you very much.
Okay, thank you very much, Professor Tony Toharudin, for your amazing presentation. And I think today we embark a journey to explore the transformation of education in Indonesia through the lens of data science in Indonesia, which its rich cultural diversity and immense potential. has been actively working toward improving an educational landscape. In this presentation, Professor Tony delved into the critical role that the data science plays in understanding, enhancing, and shaping the future of education in this vibrant nation. Also, in today's digital age, the evolution of education is not merely confined to traditional classroom. Professor Tony gave us the illustration from the video of metaverse. So it's extend into the realm of the metaverse, where the fusion of technology and data science is reshaping how we learn and teach. Today, we embark on an enlightening exploration into the development of education in Indonesia, and we do so from the unique vantage point, a perspective that integrates the power of data science with the emerging metaverse. Okay, and now Professor Tony Tohardin Presti will answer some questions that were sent us during the presentation. For the participant who would like to ask a question, please use the raise hand function and at participants menu on your Zoom. Okay, let us check from the meeting chat.
Yeah.
Oh, so many questions, Professor. Professor Tony, I'm interested in your presentation from Miss Siska Febia. How accurate the result from realistic cloth simulation? Is it already trained for all kind of cloth on and material? Is it any information regarding the computational cost, such as of this system? Is it capable to implement massively? I assume it will be the next level of e-commerce system if we could use it, because people can directly consider to choose the clothes they are buy online.
Okay.
Okay, I think one by one question, Professor, is several questions from. Okay, you may respond directly.
Okay, so when you saw the video of our presentation, yeah, if you see the question, how accurate the result from realistic R simulation, so we can use the simulation of, yeah, as you see in our presentation, we can analyze the data to find the accuracy of the simulation there. So I mean, it's really easy to see the accuracy of the simulation of our presentation, and it's already trained for all kind of clothes and materials. Yes, of course, and we already trained for all kind of clothes and material. Is it any information regarding the computational cost such a system? Yeah, it's information regarding the computational cost related to the simulation. It's applicable to get the information regarding the computational cost. That's all, yeah. It's too small there.
Okay, thank you, Professor Tony. I hope Siska already your question is answered.
We try to answer clearly. Siska, one moment, please. So the accuracy of realistic cloth simulation results can vary, but can be improved with fine-tuning and high-quality three-dimension models. Whether it's trained for all materials depends on the software use. And the computational cost varies based on simulation complexity. Implementing it massively is feasible but requires resource optimization. In e-commerce, realistic cloth simulation enhance the shopping experience by showing how clothes fit virtually. However, a balance between realism and efficiency is very crucial for user experience. That's all, Mbak Siska.
Okay. Thank you, Professor Tony. We go to the next question.
Yeah.
Dear Professor Tony, thank you for valuable insight. Allow me to pose a question. What step can the Indonesian government take to promote the integration of data science and the metaverse in education?
What step?
The Indonesian government.
Can you repeat?
Yeah. What step can the Indonesian government take to promote the integration of data science and metaverse in education?
Okay. The Indonesian government plays a pivotal role in driving the integration of data science and metaverse in education. Maybe I can explain here some steps the government can take. Invest in digital infrastructure, and then also teacher training programs, and the most important is curriculum revision. Collaborate with educational institutions to revise curricula, integrating data science and metaverse related subject. Ensure that the curriculum reflects the evolving demands on the job market. By taking those steps, the Indonesian government can create an enabling environment for the seamless integration of data science and the metaverse in education, ensuring that the country's educational system remains competitive and relevant in the digital age. Maybe that's all.
Yes. Thank you, Professor. Nice explanations. Before go to the next question in the chat room, maybe from the audience wants to directly ask to our speaker, please raise your hand or directly deliver your question. Anyone? Okay. We go to the next question, Prof. Tony. I have some question regarding to the integration of metaverse and remote or virtual learning. First, in what ways can we guarantee that the utilization of the metaverse in education remain inclusive and accessible to every student, promoting equality? And second one, are there any potential risks or adverse effects associated with implementing the metaverse in education?
Okay. Thank you for the question, Auliati. So, to promote inclusivity in metaverse-based education, we can ensure affordability, create accessible interface, improve internet access, provide training, and also we have to adapt content. Yeah. So potential risks include privacy, security, and over-reliance on technology, which need strong policies and also monitoring to mitigate early warning system to mitigate the case. Maybe that's all. Yeah.
Okay. Yeah. Thank you. Dr. Lia Sandita, you raise your hand. You may you want to deliver your question directly, please.
You for the opportunity, Dr. Budi Nugroho. So thank you, Prof. Tony, for joining us in this session. I would like to ask one more question. It is related to the security and data challenge issues. I mean, security and data privacy. So
Yes.
what are the data privacy and security challenges should university consider when they are integrating metaverse technology into their educational program? Do you have any insights related to this? Thank you very much.
Yeah, if we look to the development of technology right now, our government have to have some regulation for that, yeah, to make the data is safety for everybody here in Indonesia. So I mean, the regulations for our government is very important to make as soon as possible related to the development of technology right now. So if we late to make a new regulation for that, I think it's very dangerous for us, especially for community of like, for example, like higher education, or also researcher, or also the government staffs. So I mean, regulation is more important to make as soon as possible. Yeah, I think right now also our government in line to this situation. So one more, I said that regulation has to in line with our situation right now. And I think to address these concerns, also universities should implement robust cybersecurity measures, including firewalls, encryption, and also access controls. Yeah, and regular security audits and employee training can also help to protect our data. Thank you.
Thank you very much, Professor Tony. So there is such an awareness from the government, but the program has not implemented yet.
Yes, yeah.
Okay. Thank you very much for your answer.
You're welcome, Leah.
Okay, thank you very much, Professor Tony and Leah, for the nice discussions. And if you still have any question or comment, you may contact Professor Tony later. Okay, we still have 5 minutes and we have one more question, I think, Professor Tony. Is it okay?
Yeah, that's great.
Okay. From Andi Jalal. Metaverse replaces real-world social interaction with virtual interaction. This, of course, reduces the opportunity to learn social skills and empathy that are needed in everyday life. Do you think the metaverse can overcome this? Okay, Professor.
Yeah, thank you, Mr. Andi Jalal. Certainly, the metaverse can facilitate also social interactions, I think, and also skill development through immersive virtual experiences. So don't worry for that. And yeah, back to my statement, the regulation of our curricula in higher education, maybe we have to attention for social interaction or also ethics, yeah, to metaverse methods. So I mean, one more, the metaverse can facilitate social interactions and also skill development. So yeah, in Indonesia, religion also more important to involve in this method. So I mean, don't worry for that, Mr. Andi. Maybe that's your question, right? Or
yes, thank you, Professor Tony.
yeah.
Perhaps Mr. Andi want to respond the answer from Professor Tony. Yeah, I think we don't have to be worried, right, Professor Tony?
Yeah, and Society 5.0 now exists, yeah, in our situation. So I mean, the social interaction and skill development through immersive virtual experiences also now.
Thank you very much, Professor Tony, for answering those questions. Actually, there are several questions that's sent directly to my to direct message, but because we run out of time, I think later we can I can deliver the question directly to you, Professor Tony. Is it okay? And for the great presentation, it was a pleasure to have you with us. So this concludes the keynote speech session. Thank you all for attending. We hope you have learned and enjoyed this amazing presentation. That's all, Ms. Elvira. I think we have end up this session. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you very much, everybody, and
Wait,
Eh,
thank you, Professor Tony.
Apologies to
Taharudin.
leave Zoom.
Sorry, Professor Tony, we have
Okay.
We
Please
still
wait
have
a
a
minute.
photo session,
Yeah.
maybe
a photo session. Please
minute.
wait a minute. Yeah,
5 minutes.
Okay.
need to have
Thank you,
PhD.
Professor.
Exciting
You're
keynote speaker
welcome.
and Budi Nugroho for assisting us in engaging in the discussion. Would like to give a token appreciation for Professor Tony Toharudin, PhD, and have a short photo session. Ms. Wardato, please take a photo. Okay. Yeah, thank you very much, Professor Tony.
You're welcome. Success for all.
Thank you,
Yeah,
thank you, Prof.
thank you,
Thank you, Prof.
Professor
Thank you,
Tony.
Prof.
Thank
Tony.
you.
You-
Thank you very much
Thank you
for
very
the
much.
time for your presentation. Yeah, thank you, Mr. Dr. Budi Nugroho. Okay, we want to continue with another agenda. Okay. Let's give us virtual applause for Professor Tony Toharudin, PhD, and Dr. Eng Budi Nugroho. And ladies and gentlemen, now we will have a 5 minutes break. We will start the parallel session at 10:50. We will have a parallel session in 4 breakout rooms. The track for room 1 and room 2 is for data science. Room 3 is for informatics and data processing. The last room is merger from ICT's application and information and data processing. Remember to write your username as indicated by the conference rule, so our committee can assign you to your breakout room. Please join on time. Thank you and see you in the next session. Oh, yeah. Okay, sorry, one again. I want to remind you that before closing IC3INA, we will announce the best paper and the best presenter. So prepare your best presentation. Thank you. For the presenter and participant, you can join the breakout room by clicking the breakout room accordingly. If you have any trouble entering the breakout room, you can directly contact the host, whose username is IT Help Desk for help. Thank you. Ladies and gentlemen, we are now having a break session. We will have the third keynote session followed by a parallel session starting at 1 p.m. Please join on time. The participant may either stay online or leave the meeting. However, for those who leave the meeting, we require you to join the conference again at 1 p.m. in Indonesia Western Time using the Zoom link provided by committee. Thank you and see you in the next session. Good afternoon, ladies and gentlemen. I hope you enjoy your lunch. Welcome back to IC3INA Conference 2023. We inform you that the conference will be continued in a couple minutes. Please make sure you're already joined to the Zoom meeting. Thank you. Welcome back to all the honorable guests and participants. I hope you all feel refreshed and ready for the next agenda. We will have the third keynote session delivered by Professor Wu Yan Cheng from National Cheng Kang University, Taiwan. The session will be hosted by Dr. T.R. Lindung Paningwatan Manik from the Research Center for Data and Information Sciences BRIN. Please, Dr. T.R. Lindung Paningwatan Manik, the session is yours.
Thank you, Ms. Elvira, for the introductions. Welcome, ladies and gentlemen, to the last keynote session in this conference. I hope that you are still enjoying our conference. The speaker of the keynote lecture on this session is Professor Wu Yan Cheng. He will talk about NLP with explainable AI entitled Truth or Fake, the natural language processing with explainable AI approach for the ESG in the post-epidemic era. Professor Wu Yan Cheng is affiliated with National Cheng Kung University. He got doctoral degree from information management from National Chiao Tung University, Taiwan, and now serves as professor of engineering science at National Cheng Kung University, Taiwan. His research interests are artificial intelligence, soft computing, data mining, deep learning, context awareness, machine learning, and social network mining. He got achievement from Stanford University that stated that Professor Chen is one of the top 2% of highly cited researchers in artificial intelligence. He has 186 publications in Google Scholars with more than 5,000 citations and 33 H index. He also co-edited several special issues in international journals, such as IEEE Transaction on Engineering Management, IEEE Access, SCM Transactions on Management Information System, SCM Transaction on Sensor Networks, Computers in Human Behavior, Applied Soft Computing, Information Fusion, Journal of Real-Time Image Processing, Sustainable Cities and Society, Neurocomputing, Supercomputing, Enterprise Information Systems, Journal of Medical and Biological Engineering, and also Computational Economics. He also serves as editor-in-chief and associate editor in several international journals, such as International Journal of Big Data Analytics in Healthcare, IEEE Transactions on Engineering Management, IEEE Access, Applied Soft Computing, Granular Computing, Human-Centric Computing and also Information Sciences, Journal of Information Processing Systems, International Journal of Social and Humanistic Computing, while he is also an editorial board member on several SCI journals. Without further ado, let's begin the presentation. The screens and time is yours, Professor Chen.
Dear delegates, ladies and gentlemen, and dear friends, good day. I am Nguyen Chen, a professor from National Cheng Kung University. I'm honored and delighted to meet you, distinguished and outstanding scholars on the IC3INA International Conference here. Please allow me to give my hearty welcome to all of you present. Thank you for your coming by online meeting. In addition, I would like to offer my special thanks to Dr. Rezi Echo Karaka invitations. The topic of today's speech is about the true or fake, the NLP with the Chai approach for the ESG in the post-academic area. It's my personal email. If you have any questions or ideas, then please drop me a mail. We can discuss in details about research and collaborate each other. My current research interests including artificial intelligence, soft computing, bio-inspired computing, data mining, the deep learning, and the machine learning, with more than 150 publications in several journals such as the IEEE Transcations on Fuzzy Systems, IEEE IoT, IEEE Sensors, IEEE SS, and several ACM Transcations journals. Besides, I'm also the editor-in-chief on International Journal of the Big Data and Analysis in Healthcare, and I also serve as several associate editors on IEEE TM, IEEE SS, Journal of Information Science and Engineering, and Quality Computing. And you can see my publications on Google Scholars or the DBLP. In addition, I am also the top 2% of the scientists in the world by the Stanford University in 2021 and 2022. Today, there are 4 sections of this research of this speech, including the introductions, literary review, research methodology, and the experimental design and the performance evaluations, and finally its conclusion. Okay, the first part about the introductions. The research background of this research is the climate change. It has become one of the important issues that the world needs to face in recent years. The related events such as the wildfire in Hawaii and Australia, and the increasingly common heat waves everywhere. So, reliable information about the climate change is of great significance for consumers to make informative discussions, including the risk management and the control. For example, consumers can choose the product with the low carbon emissions as their primary buying choice, and investors can also determine the transformation effects of the enterprise based on the carbon emissions. So, the reliable information is, about the climate change is very, very important for consumers to make their investment decisions. Okay, the society and the investors generally accept companies to take positive measures to address the climate change. So the task force on climate-related financial disclosures is called the TCFD in short. Working groups were proposed in 2015. The TCFD is a volunteer disclosure guide which aims to provide investors and other company stakeholders with a fair standard of climate information, which has been adopted by many governments and companies. The TCFD report, compared with other reporting framework, it focuses on the risks and the opportunities that climate change brings to companies to help them transition to low carbon. The research motivations of this research is about allow the society and the corporate investors strongly demand that all companies must disclose the climate change related information in their financial reports. Many companies chose to disclose less or not disclose their weaker parts to reduce their own disadvantages. With the evolution of social concepts and the climate changes, more and more companies will disclose their information on climate change in their financial reports. Therefore, more and more researchers focus on TCFD analysis. There are two main types, analyzing the degree of climate change and the community sentiment analysis on climate change. But certain researchers focus on analysis the concept of the financial report to find out whether the company supports or refutes various aspects of the climate change. Okay, so the purpose of this research is about use the deep learning models and the explainable AI to analyze the paragraphics with the TCFD relatives of the corporate financial reports to analyze whether the company supports or refutes various aspects of climate change. And then the research combined with the explainable AI is called the AI in short. Consumers can clearly understand which words in the financial report are more important for understanding the company's attitudes towards the climate change. The objectives of this research, there are 3 points. The first one is this research compares different deep learning models and find out which pre-trained model they can give better detection results. And the second, you want to solve the problem of the data imbalance. This research uses and compares the performance of different kinds of the text augmentation methods. And finally, this research applied the AI model to explain which variable on the model constructions can affect the final prediction result. Okay, the second part is about a literary review. Okay, you can see this figure. It is about a TCFD framework, focus on how companies can reduce the risk and create the opportunities from the climate change. The risk can be divided into transformation risk and the physical risk, corresponding to the change in commodity markets that may be caused by climate change and the increase in the opportunity costs caused by the corporate changes. And the opportunities can be divided into the 5 parts can cooperate with each other, makes the company generate income. And the risk and the opportunities cooperate with each other to form a strategic planning and the risk measurements for climate change and lead to financial impact. Then conduct an overall discussion and adjustment according to the financial impact, such as the income statement, cash flow statement, and the balance sheet. Then I will discuss the risk and the opportunities in the following slide. This slide shows the 4 core elements of the TCFD. Governance is referred to whether the climate-related issues are taken serious by the organizations and how to manage the risk and the opportunities of the climate. And the strategy is referred to how investors and the stakeholders recognize how climate issues affect the organization's short-term, medium-term, and the long-term business financial planning for future performance predictions. And the risk management is referred to how stakeholders and the investors identify, management, and evaluate the climate-related risk so as to assess the overall the risk situations and the management activities. Finally, the indicators and the target. It means it is necessary to understand how organizations monitor and measure the climate-related opportunities and the risks, and to more efficiently assess the risk adjustment and the potential rewards, climate-related distress levels, and the peer comparisons. Okay, this slide shows the two risks of the TCFD. The first one is about the transition risk. It is referred to the risk arising from the low carbon transformations faced by the enterprises. It contains the policy and the legal risk, technology risk, market risk, and the reputation risk. This type of risk is that due to the climate changes, companies need to take additional measures and enhance the corporate values or respond to change in market and the consumer habit. The second one is about the physical risk. It means the enterprise will face the climate and the disaster impact caused by the climate change, and they need to be included in the current risk management of the organizations in the future. This type of the risk is that the environment impact caused by the climate change cause the company to pay extra cost to improve the working environment and the maintain product quality. Okay, this slide shows the 4 opportunities of the TCFD. The potential opportunities sought out by TCFD for enterprises contain resource efficiency, energy resources, and the product and the service, and the market and the resilience. These several opportunities reveal the enterprises can grasp in the face of the climate change, including how to enterprises transformations, market expansions, and corporate image enhancement. For example, developing the renewable energy and to reselling it to the third parties in needs, bring the new business opportunities, or shift the traditional business model to sustainable procurement and the green supply chain management, gaining more favor and the cooperation opportunities. Okay, a widely used and an important MLP is called a natural language process. Is text classifications. It is mainly used to classify the large amount of the text data according to the classification labels of a single topic specific text sequence. The sequence may be formed by the sentence, paragraphics, or the full article, or based on its sentiments. This research related to the text classification applied to TCFD can be mainly divided into kind of a data set. One is the sentiment analysis, which is applied to the social network post, and another is the classification of two label texts. One is the positive, it's mean the support, and another is a negative, it means refute for company financial report. Okay, you can see these figures is a very important issues about the data size. Since a lot of the data in real world are unsorted, imbalance are very common. If the analysis is performed directly, the performance of the model in classifications will be affected. So the data generation methods are used for the imbalanced data. The most common generation model is called GAN. The full term is about a generative adversarial network. In short, it's called GAN or GAN model. Data imbalance usually reflect an unequal distributions of the cases within the data. For example, in the credit card fraud detection data set, most of the credit card transactions are not fraud, and very few cases are fraud transactions. This leaves us with something like the 50:1 ratio between the fraud and the non-fraud cases. So there are two main research methodology to solve the data imbalance. Is called undersampling, and another is oversampling. And this about the ChaiAI. It's a very popular and new challenge of the artificial intelligence. As we know, the deep learning and the machine learning are major branches of the AI. Current AI system can run many high-performance algorithms and recognize the possibilities. However, there is a concern over the transparency in AI developments because we can only know of the input information and the output results without having access to its entire computation process and other data. So it's called a black box. The nature of the deep learning and the machine learning makes their inner working difficult to understand and interpret. So the deployments of the explainable artificial intelligence, it's called ChaiAI, can help explain why and how the output of the deep learning and the machine learning models can be generated. So as a result, an understanding of the functional behavior and the output of the models can be understood, reduce the bias and the error, and improving the confidence in decision making. Okay, the concept of the ChaiAI is how to explain the results of the model through the future attributes. For example, the screenshots show the sentence, I would like to know the actual number of the people die of the COVID-19 in this page. I have a feeling that the numbers would start as O. After the ChaiAI analysis and the interface, we can understand the key features in this sentence and show the attributes of the features. As a result, the term, the died, and the stunned means the strong, very strong negative sentiment. On the contrary, the term like or no shows the positive sentence and the emotion. So you can understand we can use the ChaiAI, this interface or the function or algorithms to explain why we use the deep learning model to solve the text analysis, text clarification problem will be a good choice. Okay, the third part about the research methodology. This slide shows the main architectures. There are 5 main steps, including the data preprocess, data augmentations, deep learning modeling, experimental AI, and finally is about climate change information for consumer electronics. Okay, so Since this data itself is imbalanced, this research uses the game-based model to deal with the data imbalance problem. And in the third step is the deep learning models. We adopted the novel BERT framework to classify the climate change related text paragraphs in the financial report. And in the fourth step is about model comparisons. This research we use the BERT, raw data, and the common BERT used to detect the sentimental analysis of TCFD. Finally, the model will output the performance evaluations by the confusion matrix and also explain the final prediction results by using the AI technology. Finally, the consumers can understand the performance of the different prediction models and how to make their own decision. Okay, the first step is about the data preprocessing. In this step, the data set of the research was collected through the website and the bank official website, collect from the TCFD report or sustainability report, the CSR report, and the annual report. Finally, this research adapt the TCFD report, which provided by the 147 companies. The information related to the TCFD disclosed by these companies will be detailed. The correcting time was from 2018 to 2021. Okay. In the second step, it's about data augmentations. The amount of data in this data set is about 2,746. Due to the imbalance of the current data, the amount of the data for supporting label is twice of the refute label. Therefore, this research used two data augmentations method to generate the data from only the refute label. After the generation, the dataset is balanced, and the data variance reached 3,896. Okay, the data augmentation in this research, we mainly use the GM model. It has achieved great success in the image generation, so this research applied the GM model to generate the text. Okay, but the difference between the text and the pictures is very, very different. The vector is not like the pixels of the picture and pictures. The correlations between the continuous pixel is very high. However, in the research, the generation target is about the text. It means the discrete sequence of the tokens and the words. So the learning performance will be impacted. Okay. A major reason is that the discrete output of the generative models, especially the text, makes it difficult to transfer the gradient updates from the discriminant models to the generator models. Therefore, this research adopted the sequence scan. It's called SEQGN, the sequence scan, to deal with the text and the paragraphics, especially for the two very short sentences. The sequence scan adopts the random storage in reinforcement learning, it's called RL, in the generator model and bypass to the gradient differentiations. The details about the sequence scan can be found in Google or other journal articles, but it's very complex, so I cannot discuss it very in details in this speech. But it's very popular, the sequence scan. Another one is called Manigan. It's a more new deep learning model about the text mining. The Manigan takes a different approach to solve the problem of using the GAN models for text generations. Comparing to the sequence scan, the Manigan made two adjustments in the following. The first one is about the learning features from the data distributions. it uses the self-normalization importance sampling by defining a new generator objectives. And the second one is about to reduce the variance of the gradient signal. It uses a mixed sampling from the true data and the generated data distributions. Through these two different samplings, the money gain can improve the model optimization, both on the performance robust and the important features extraction. And this research also used the rank gain. The rank gain argues that the outputs of the generators and the discriminators of the original GAN model for text argumentations is limited to simple binary classifications, thereby affecting the performance of the text generation models. To address the diverse range of the natural language expression, the model employs the ranking techniques to compare the sentence generated by the models against the real sentence. So in the research, we use three data augmentation methods: sequence gain, money gain, and the rank gain. Okay, the main research model is about a language model. We use the language model. It's based on the deep learning to recognize or classify the correct emotion of the text or the article or the TCFD relate information. So the BERT, the BRT, the BERT, it is a deep learning model for natural language preprocessing by the Google. The BERT includes two stages in the training process. The first one is the pre-train, and the first one is the fine-tune. The pre-train stage is the Google's use of the unsupervised learning, using a large amount of text data, such as the wiki or the book corpus for the model training. The fine-tune stage is through the attention mechanisms in the model to improve the model parameter setting, and also used by directorial structures instead of only using a single model for unidirectional predictions, which can make the model more efficiency for understanding the contextual relationship in a sentence. Okay, this is the second model for a language model. It's called raw beta. Raw beta is a robust version of the BERT model. The raw beta model has made the following modifications based on the BERT model. The first one is about remove the next step prediction. It's called NSP in short. To reduce the error that may be caused when the model is detected or generated. The second point is to improve the mask encoding method. Raw beta use a dynamic encoding method to deal with when the new sequence was input. Okay. The finally language model is called the common BERT. The common BERT is based on the raw beta model and uses 1.6 million common relate text to train the model, the new model. So it's called common change. Include the articles collect from the refinitive workspace marked with the topic of the common change. So you can understand and realize why we decide to use the common BERT to be the main language model to investigate the TCFD issue. After the training is complete, the model can predict the text data relate to the common change more aggressive, and it is the primary recommended model in the field of the common change prediction. So we use the simple BERT model and the beta and the common BERT of our research model about the language like language clarification. Okay. The final step is about the Chai. We use the very important index. It's called Shapley. It is one of the common explainable AI Chai model structures. The Shapley value is designed from the game theory, and you can see these equations. The lower the value means that the future is negative corrected with the prediction target. If the value is high, then it means the future is positive correct with the prediction target. So it can be very easy to detect or understand the relations or corrections between different words. Okay, so this is the fourth part is about experimental results and the performance evaluation. Here is the hyperparameter settings of the game model. The setting values were decided by the try and error or use the reference support. So you can see we use the batch size, input length, future size, and the numbers of the totally game models. But as we know, there are two sub-models of the GN. One is the generators, and another is the discriminators. So we use a different performance index or hyperparameter settings of the different models. In the generated models, we use the model unit, epoch, learning rate, and the activity function. We use the softmax to set up the generator models. In the discriminators, we use the model units, epochs, learning rate, and the optimization function and the dropout. Okay, so mainly we use the try and error this process to find out the suitable parameters. Okay, here is the hyperparameter setting of the BERT model. These setting values were decided by the try and errors and the reference support. So you can see the batch size, epoch, learning rate, dropout, and the activity function. We use the ReLU, and then the maxima input sentence length, and the training, validation, and the testing ratios. It's about 80 and 10 and 10. Okay. It's more spatial. You can see there are several evaluation metrics of this research. The accuracy recall prediction F1 score is mainly can be calculated from the matrix, confused matrix. But in this research, we use the NLL. The NLL is called a negative log likelihood. It's used to evaluate the generation's efficiency of the model. It is also the loss function that measures the difference between the generated data and the real data. By minimize the NL loss, the generator network learns to produce the sampling that are more similar to the real data. Besides, the accuracy recall prediction and the F1 score are the common performance metrics from the confused metrics. All the metrics are used to evaluate the classification efficiency of the deep learning model. Okay, it's about a confused matrix. As we know, it's a very popular performance evaluation index and the approach. Okay, there are three different experimental designs. The first one is about we want to know what is the best model for the test argumentations. Therefore, the performance of the three different GN models were compared. Finally, the similarity between the generators of the mulligan and the original data is the highest. In the second experimental, there are three different bird models called bird, raw beta, and the common birds were compared to analyze the effects of the raw data. Finally, the detection effects of the common bird is the best. And you can see the figures. The left side means the loss function, In the right side is called a confusion matrix. And you can see the validation loss rate will it is higher than the training loss rate. It may be because the amount of the validation data is very small, and it just captures the less converted part of the training data, result in a difference between the distributions of the validation data and the training data. Furthermore, while both training and the validation loss are initially low, there is a gradual increase in the validation loss compared to the training loss as the model undergoes to training. Okay, is the third experiment. There are 3 different BERT models were compared to analyze the effects of raw data after augmentations. Okay, in this research, the augmentation, we only use the melakukan because we know that melakukan has the best performance. So, from the perspective of the evaluation indicators, the detection effects of the common BERT is also the best. Okay, so you can see the loss function reducing the process of the left side pictures, and the right side shows the confusion matrix. Finally, is a different research results. It's about the II. The text within the red block indicators the positive variables associated with the model's detection of the refutes, whereas the text with the blue block represents the negative variables. The intensity of the color signifies the degrees of the influence exerted by each features. Okay, in this page you can see the text with the red block indicates the negative variable associated with the model's detection of support, whereas the text with the blue one represents the positive variables. The intensity of the color signifies the degree of the influence exerted by each features. Okay, as conclusion, the goal of the research is to predict the climate change related to the paragraphies in the financial report. It is formulated BERT related models, which is fine-tuned on climate change related text. The accuracy has achieved at 90%, especially when there is enough data and the amount of data in each category is related or balanced. This research not only uses the evaluation criteria commonly used in the past to evaluate the model, but also use the novel explainable AI to explain the model. From the results graphics, it can be seen which words in the climate-related text have a significant impact on the prediction targets, which of the graph help to consumers when building the financial reports. However, there are several research limitations. It is the TCFD-related research fields have just begun to receive attention in several years. So there is not much related information in the data. So many companies do not publish too much about TCFD-related contents in their financial report. So it's very difficult to obtain the related information. So in the future, maybe we can extract through the abstracts or find a paragraphic related to the TCFD, and then use the deep learning model to analyze and use the II to explain the related concepts to help consumers and the navigators make decisions and the evaluations. Okay. I think it's a roadmap to the AI. So in this research, we do not use so many statistics analysis, just like the linear function or time series, or use the SPSS or SAS tools. However, we use the many models about deep learning. So it's called strong AI, the strong AI. The research topics about NLP and the sentiment analysis. So we use the very, very popular deep learning models for the language solving, just like the bird, raw beta, and the common birds. Okay. In the weak AI, it's referred to the machine learning or the data mining. In this research, we use the data augmentations. However, we do not use the very popular undersampling or oversampling machine learning algorithms to solve the data augmentation. In the contrary, we use the deep learning model. It's called multi-gain, and the sequence gain, and the rank gain to do the data augmentations. Okay. Okay. So finally, thanks for your listening, and also very special thanks for Dr. Rezi Eko Karaka. Thank you for your invitation and the listening. So welcome to receive your message about my speech today and any questions about this research. Thank you.
Thank you, Professor Chen, for your presentation. Unfortunately, Professor Chen cannot join us because he is sick. And however, we are delighted to have one of his PhD students, Yiwei Lai.
Yeah.
Hi, are you there?
Yeah, I'm here.
Yeah, thank you for joining us, Yiwei. Are you involved with Professor Chen about this keynote lecture in this topic?
Sure. I can have some QA.
Okay. So, if any participants have questions about the lecture, please go ahead. You can raise your hand or type in the chat box. Yiwei will try his best to answer your questions. So please go ahead if you have the questions. Please deliver it in the chat box or directly by raising your hands. Myself, I have my questions about the data set that used in this research. It was mentioned that I can show the presentation actually. So in the presentation, Professor Chen mentioned that the data set used is TCFD data set. And is it from the companies or is it from Peters? Do you know how the data was retrieved and how it was labeled?
Which? Do you mean what is the TCFD like list or what?
Yeah, I couldn't find the slide number.
Or I share the I share the PowerPoint. I share the PowerPoint. You can X which one do you want to X?
Yeah,
okay.
This one. I want to ask about the data retrieval. The slide mentioned that the amount of data in the dataset is 2000 and something, and how was the data retrieved and how was it labeled?
Okay.
Who was the
Okay, this amount of data in the dataset is 2075 and 2000 and 2000 this and 2746. This is from the collected from the web and from 1 to the 147 bank and from the 147 companies reports, and this 147 company report is being it's being over present the TCFD content, so we collect it from this. And how it's labeled when we sue the expert, that expert is the financial this is the expert is the professor of the economics, and the data is segmented by the professor of the economics. Okay.
Thank you for your answer, Yue. I have questions in the chat box on page 41. Let me see. Okay, on page 41, Nguyen mentioned the NLL value. Is this an abbreviation for negative log likelihood? Could you please clarify why you have chosen to use this measure? I'm quite familiar with the concept of using degree probability, but it seems that GAN is not related to it. Can you provide some insight into this? You could answer.
Why this research use the negative log likelihood? Because this this question I need to think about it. Please wait me for a second.
Sure. If you could not answer the question, it's okay. We will ask Professor Chen later and come up with the answer later. So, Pak Rezi, I think you need to wait for the answer from Nguyen. Okay, the next questions from Agung Santosa. I have questions about the climate bird model. Is it trained from ground up, or it is based on existing bird model? If it is from existing bird model, is the fine-tuning process done for the whole layer or including the embedding layer, or it is done only the specific layers? Yue, could you answer this question? Okay,
climate bird is pre-trained. Is using a pre-trained model about Roberta, and it's fine-tuned on the climate bird related data. So in this question, I can it's only use the fine-tune data, fine-tune process on the TCFD related data, and it's done for the it's also the process done for the whole layer, including the integrating layers.
Thank you, Yue, for your answer. I think I have another question from Busno. I was actually going to ask the same question. I think this is questions about the data. Because for the data scientist viewpoints, the data description is very interesting. Could you describe more about the documents? Is it in the form of paragraph or the document is mainly tabular? Yue, could you answer this question?
The research data, the research document, it is a part of the data was extracted from the form of the paragraph in the financial report.
So one document, one label, right?
One paragraph, one label. Yeah.
Okay. Thank you, Yue, for your answer. Is there any questions? Any more questions about the lecture brought from Professor Chen? Yue can answer. Or if you have more questions, you could deliver directly to Professor Chen through the email. I think Professor Chen will be happy to answer in the future. Otherwise, we could close this keynote session. Thank you again, Yue, for coming to our conference. We are very happy to have Professor Chen's lecture, and also you're coming today. I think we have a certificate for token appreciation. Is it ready?
Ready? Okay.
Okay.
Yeah. Once again.
Thank you. Yes. Thank you.
Yeah. We would like to give a token. Yeah. Okay.
Yeah. We will have 2 certificates, right? Okay.
Yeah. Okay. We would like to give a token of appreciation to Professor Mu-Yan Cheng and Mr. Yi Wei Lai for the insightful sharing. We will have a short photo session, but because of his health of Professor Mu-Yan Cheng, his PhD student will represent him in the hand hopper. For Mr. Yi Wei Lai and Professor Mu-Yan Cheng representative, please receive the certificate. Okay. Yeah.
Thank you.
Thank you very much. And thank you, Yue. Thank you very much.
Thank you, Professor Mu-Yan Cheng and Mr. Yi Wei Lai and Dr. T.R. Lindung Paningwatan Manik for the informative and interesting session. Again, let's give our virtual applause to Professor Mu-Yan Cheng, Mr. Yi Wei Lai, and Dr. T.R. Lindung Paningwatan Manik. Okay. We will continue. Thank you very much. Okay, we will continue to our next program. We have a parallel session in 3 breakout rooms. The track for room 1 and room 2 is from data science, and room 3 is for informatics and data processing. Please, for the presenter and participant, you can join the breakout room by clicking the breakout room accordingly. If you have any trouble entering the breakout room, you can directly contact the host, whose username is IT Help Desk for help. Thank you very much.
you.